Hi, in this video we will discuss the existence and uniqueness of Laplace transform. Laplace transform is used to transform a time domain signal ft to a s domain signal fx, where we can use the symbol L to represent the Laplace transform. So we can read this as performing Laplace transform of the ft, then you get the fx. So this is a time domain signal where you can see all the variables are in the time domain. When we perform the Laplace transform on the time domain signal, then we get the s domain signal fx. And you can see that all the variables are in s domain. In fact, the variable s is a complex number, which is x is equal to sigma plus I omega. So sigma is at the real part of x, while the omega is the imaginary part of x. In most mechanical systems, sigma refers to the decay rate or growth rate. Omega refers to the angular frequency, where omega is in radian per second, which is equal to 2 pi f. There is some cases when you perform the Laplace transform on certain ft, it might be exist. In some cases, it might not exist. So to know the existence of Laplace transform, it depends on two main characteristics. So the first characteristic is piecewise continuous. So if you have a function like this, ft equal to sin t, you obtain a graph like this. So this is called the finite continuous function. And for this kind of function, we guarantee can perform the Laplace transform. So in this case, we have a piecewise continuous function where you can see there are several functions in one graph. So between two functions, you see the point is discontinuous. So in this case, we still can guarantee that we can perform the Laplace transform of this function. On the other hand, if the point is discontinuous at infinite discontinuity, so in this case, we may not able to perform the Laplace transform. So in simple, if you have a piecewise function like this, when you perform the Laplace transform, you should be able to get some number. But if you perform some function which is not piecewise continuous function like this, then you may not able to perform Laplace transform, and when you perform it, you may get not a number. When you have the piecewise continuous function, you should be able to perform the Laplace transform, and the Laplace transform result exists. So the second characteristic is called the exponential order. So if you have a function which is exponential order, you should be able to perform the Laplace transform also. So first of all, what is exponential order? So the definition is, if let's say you have a function that has the growth rate lower than the MECT, so it will be called the exponential order. So which means if let's say your growth rate is faster, then this is not a exponential order. So based on this, you can see you have MECT at t equal to 0 here. We found that exponential is equal to 1, then you only have m. So at this intersection point, you have your m. So c must be always positive greater than 0. So in this case, you have the exponential positive t. So you can put any m and c and let it to be any real constant. So try to give the value for m and c so that this new function will have a better growth rate compared to the ft. So in this case, we found that 2 exponential 3t can have a better growth rate than the ft, where you see the ft is below the MECT function. So we can say that this function has the exponential order of 3. So let's try more example here. So in this case, your ft is equal to t. So what is the MECT that can have a greater growth rate than this curve? So you start to let the m equal to 1 and c equal to 1. So in this case, it's exponential t, and you found that t function is less than the et. So in this case, we can say the ft equal to t function is a exponential order. With that, the Laplace transform of the exponential order function exists. So when you perform the Laplace transform, you should be able to get a value from here. Let's try with the second case. In this case, you have ft equal to exponential power of t power of 2. So in this case, you try any number of m starting from 1 to infinity, and your c, you increase the number from 1 to infinity. So you see the et power of 2 is greater than the benchmark line here. So it means that the function exponential t to the power of 2 greater than your benchmark line. So in this case, we say that this function is not an exponential order. So if you have a function which is exponential order, then we can perform the Laplace transform. But for the function which is not exponential order, then we may not be able to perform the Laplace transform. So when you perform the Laplace transform, high chances you get not a number. So we have more example here. You can see this function is below our benchmark line, and 2 cos t is below our benchmark line. So in this case, both of them are exponential order, so we can perform the Laplace transform on this. In summary, Laplace transform is guaranteed to be exist if your function is piecewise continuous from 0 to infinity, and also if the exponential order, then we can perform Laplace transform. So function that is not exponential order, such as this case, okay, is not covered in this study. Luckily, in many engineering applications, so most of the signals that we acquire are piecewise continuous and as well as exponential order function. So you should be able to get the answer for the Laplace transform. So you can see in this case, if you perform the Laplace transform on the ft equal to 1, you get the Laplace transform result fx equal to 1 over x. And when you convert from the Laplace transform fx equal to 1 over x to the ft, this is called inverse Laplace transform. So we use the symbol L to indicate Laplace transform, and L inversion, so this is inverse Laplace transform. So Laplace transform and inverse Laplace transform is unique because when you perform the Laplace transform, you will always get the same answer. In this case, if you perform on a constant equal to 1, you will always get the answer 1 over x. And when you take the inverse Laplace transform for the 1 over x, you will always get 1. So it is always unique. So you can see that if you take the original signal and you perform the Laplace transform, you obtain 1 over x. And when you convert back to the time domain signal by using inverse Laplace transform, you get back the ft equal to 1. So we see no data loss here, and the process is unique. We said that we use the small letter f to indicate the time domain, and capital letter F to indicate the S domain. You should be able to read this symbol. So for the first one, it will be Laplace transform of the ft signal. Second one, Laplace transform for the fx signal. Third one, inverse Laplace transform of fx signal. Lastly, inverse Laplace transform for the ft signal. So when you perform Laplace transform on ft, then you should be able to get fx. So if you perform inverse Laplace transform on the fx, you should be able to obtain the ft. So this one is correct. So these two cases, if you perform the Laplace transform on fx, you should get error. Okay, since it's already in S domain, we cannot perform Laplace transform again. So since this one in time domain already, so we cannot perform the inverse Laplace transform again. So this is error, so don't do this. So this is your scope of study. You should be able to solve the ODE problem using the Laplace transform and inverse Laplace transform. So this is your strategy. So if you have one ODE problem like this one, and the initial condition is given, so this equation is written in time domain signal, where y double prime is equal to dy over dt squared, right? So it's in time domain. In this study, you will learn how to perform the Laplace transform and convert everything to the S domain. So in the S domain, everything becomes algebra, where you can just use the plus, minus, divide, multiply to solve the problem. So in this case, you get the y to be, okay, we cancel this, divided by x squared minus 1. So from here, you can easily perform the partial fraction. Then you can find the partial fraction decomposition like this. And later you will learn how to perform the inverse Laplace transform to get the final answer. So it's very important for you to master the Laplace transform and inverse Laplace transform in this study.